our lesson is going to be activity oriented to ensure that you actually understand it from the real world. Welcome once again. My name is Francis Yaba, the video tutor in this particular presentation.
Objectives. By the end of this lesson, the people will be able to derive the formula for calculating the volumes of cubes and cuboids, calculate volumes of cubes and cuboids given the required data, solve real-life problems on the volumes of cubes and cuboids. Relevant previous knowledge. Cubes and cuboids are three-dimensional figures, meaning they have length, width, and height. So you're looking at the figures, they have length, and of course they have width, and they have height. So the figure to your left hand side is a cube, and the one to your right hand side, of course, is a cuboid. Considering the cube on the screen, you've seen that it has three dimensions: length, width, and of course height. One thing about this thing is that they have all their sides to be equal, meaning length is equal to width, and of course the width is also equal to the height. Cuboids do not have all their sides to be equal. And looking at the cube on the screen, of course, you've seen that it has length, it has width, and it has height, but they are not equal. The concept of volume. Volume is the amount of space occupied by a three-dimensional figure. Volumes form plane surfaces initially, then rise up to form height, making them, of course, three-dimensional.
Okay, in explaining further, looking at this real object, we get to realize that we can only describe it based on how tall it is, how wide it is, and of course, how long it is.
That is why cuboids, like other solids, are three-dimensional. Let's consider the figure on the screen. The figure on the screen is actually the unit cube. It is 1 unit long, 1 unit wide, and of course 1 unit tall. The measure of the volume of an object was brought about based on the number of unit cubes that could fit in, of course, in any three-dimensional figure. Volumes of cuboids. Let's consider this activity. Consider the cuboid below, and of course, trying to fill it up with unit cubes. Let's count the number that may enter into it. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and of course 16. So this is what forms this particular cuboid. So by counting the number of unit cubes, we can say they are of course 16. So the 16 unit cube fillings gives us the idea on the amount of space, of course, this particular figure occupies. Investigating for the formula for the volume of a cuboid. Consider the cuboid on the screen and counting the number of cubes along its length. We have 1, 2, 3, and of course 4. That gives us 4 cubes. And counting the number of cubes along the breadth, we have 1, 2, and of course that sums up to, of course, 2 cubes. Then looking at the number of cubes at the height and counting them, we have 1, 2, and that sums up to, of course, 2.
Try and multiply the counts we made at the various dimensions. And of course, you realize that the answer is 16, which equals the manual counts we made previously.
Generalization. The volume of a cuboid is equal to number of unit cubes, forming the length, times number of unit cubes, forming the width, times the number of unit cubes, forming the height. Consider the cuboid on the screen. And considering the division along the length, of course, we have 4 divisions along the length. And looking at the divisions along the breadth, we have, of course, 2 divisions. And of course, along the height, we have 3 divisions. So you do realize that the number of divisions equal the number of cubes along the dimensions, all the dimensions throughout. So of course, since divisions is actually what we use in measuring length, we can decide to label the cube, of course, in centimeters, meters, or kilometers.
Assuming we are to calculate the volume of this particular figure in kilometers, as you can see on the screen. So all we simply have to do is to multiply the dimensions. So we multiply 4 kilometers by 2 kilometers and then by 3 kilometers, and that will give us the answer 24 kilometers cube. Remember, the volumes of cubes are calculated in the cubic form of the metric units for measuring length.
Formula for the volume of a cuboid. Modifying our previous formula, which was the volume of a cuboid is equal to the number of unit cubes forming the length times the number of unit cubes forming the width times the number of unit cubes forming the height, we can then just, of course, simplify it to now have, yes, the volume is equal to length times breadth times height, as proved in our previous activity. So in short, we can say V is equal to LBH. Volumes of cubes. Cubes have all their sides to be equal. So, looking at the figure on the screen, we can relabel it as, of course, having length all throughout, width all throughout, and of course, height all throughout, or better still, side as well, all throughout as. So in this case, we can see the volume of a cube is therefore equal to length times length times length. So in short, we can say V is equal to L times L times L, which can further be simplified to V equal to L to the power 3. Illustrative example. Compute the volume of the following figures. Solution. Representing our first figure again on the screen, we know already that V is equal to L to the power 3, where V is equal to volume and L is equal to the length. And substituting our values, we now have V is equal to 5 to the power 3, of course 5 centimeters raised to the power 3. So this implies that V is equal to 5 centimeters times 5 centimeters times 5 centimeters. And when we simplify, we should get the answer V is equal to 125 centimeters cube. So therefore, the volume of the cube or the figure is 125 centimeters cube. Don't forget, the figure we just solved for is of course a cube, since all the sides are equal. Now, considering the second one and reconstructing it and labeling the parts, we also know that V is equal to L times B times H, where V is equal to volume of a cuboid, L is equal to the length, B is equal to the breadth, and of course H is equal to the height. Take note, we are calculating for a cuboid since not all the sides are of course equal. Given L to be equal to 12 meters, B to be equal to 3 meters, and H to be equal to 6 meters, and substituting, we should have V is equal to 12 meters times 3 meters times 6 meters. And simplifying further, we should get the answer V is equal to 216 meters cube. Therefore, the volume of the figure is 216 meters cube. Consider the following real-life problem. Now take your time and go through the solution below. In summary, we learned the following. Now try out the following as assignment. Thanks for watching and see you some other time.